Good, what is it? Will I say good night, good evening, guys? All right. Can I see thumbs up if you can hear me, or you can, yeah, whatever that you can do, or you can comment on the chat that you can hear me. What I want to do, I want to look into one of the question papers of 2025 here. So if you can hear me, please tell me there. In the meantime, I forgot that I don't have a copy. I'll want to try and print a copy. Right, okay. I see you can hear me. I see from your funny names on YouTube. If to those who have apps for question papers, please look into 2020. Let me go and check if 2025 July 2025 July exam paper. 2025 July exam paper. I would wish if I could hear some. What I want to do, I want to invite maybe one who can. Okay, so I was still printing the question paper here. I just found the formula sheet first. Okay, thumbs up if you do have the question paper 2025 July. So I want you to reference there. It's because I'm live here, so I was going to manage to share the document, so it doesn't give much options to share. Okay, I think okay, I think this is the question paper July 20. Yeah, but I want us to start in question. In question. Let me see, question 5. I want us to look into question 5, then we can look into question 6 because this is the major part or the end part that you need to understand better, not to ignore it, but to make sure you solve and get marks in these questions. Start question 5 and question 6. I hope we can go to question 4 and 3 in time, but I'll be fast. I'll try to make sure that I explain and wait for comments or questions if you have them. For questions or comments. Let me write here, this is July. It's 2025 exam year. Okay, well, copy here. I want to have a hard copy next to me so I can stop sharing the screen. All right, I hope we can begin. I was waiting to see more viewers, but I think I have 13. Let's hope maybe you're sharing devices there. Look into the July 20. In fact, I think I'll even go to the WhatsApp so that I can see if we're still together. To the WhatsApp, so to confirm if we're together. Okay, so I'll be monitoring on the WhatsApp. I'll just see someone commenting on the WhatsApp groups, so therefore I'll see that there's something that I have to rectify there. All right, looking into July 2025, I said I want us to look into question 5. We can start with 5.1. 5.1. So with 5.1, question 5. Question 5. The time t and velocity v of an object moving in a medium and time t is given by. So we're given that the time t and velocity v of an object moving in a medium at time t is given by, we see that lower limit, the upper limit 100. Then we have 1 over v into bracket 2v plus 1, and in terms of v there. So now we need to evaluate t. So we have to check how can we evaluate t there. How can we evaluate t? So first of all, what we have to do, we have to integrate here. So we have to integrate, so v there represent the velocity of the object which is moving in a medium at time t. So if we have to integrate, so we need to check there. I see that when we have to integrate in terms of v, I see v is a function and the other v it's a function inside the bracket there. So what I have to do, we need to integrate there. So product of two functions there. We see product of two functions. So normally I will always inspect what is inside the bracket, if it can give me what is outside normally, and again if it was in the numerator, or even if it was this in the numerator, when I look into this, if I derive, will I get that? So I'm having a product of two functions there. So normally when we have product two functions and we see a function in disguise, the other one is a function in disguise. So what we have to try and do, we need to think of what we call by parts. So we need to think of by parts. From there, if it doesn't work out, we need to think that, oh, for an example, now we have a function in the denominator, and these functions are in factors, and we have is dividing the numerator. So it takes us to think of long division or think about partial fractions. So if it was long division, we're going to state that, oh, in the denominator, we must have an exponent which is greater than the function in the denominator. So, but this is greater than the denominator, so it takes us to partial fractions. So we need to deduce into partial fractions. So deducing the function into partial fractions, we are going to state that if we have the following 1 over v into 2v, and again it's in factors now. This is better, it is in factors. We're going to state that it is equals to, therefore deducing into partial fractions, we can say a all divided by the first factor, which is v, and therefore plus, therefore we'll have b, it is still a linear factor, so it's 2v plus 1. So this is v plus 1. Now, we know according to partial fractions, we need to multiply by this denominator here throughout the equation. So when we multiply by this expression throughout the equation, we'll have 1 that is equals to, because when it multiplies here, it is dividing, and we'll be left with 1. When we multiply here, v will divide, will be left with a times 2v plus 1. We'll multiply by this in this expression, or in this fraction. So we're going to have plus, therefore b times v, because 2v will be dividing 2v. Okay, I hope it's clear there. I'll pause a bit. So I'll just want to see thumbs up. You can just put a reaction there in the chat if at this step we are still together. Thumbs up. So is it possible to expand and use the U method? Okay, so it was going to be possible if, let's say, these two functions were both in the numerator. If both these two functions were in the numerator. So now we see that when we're looking into this, it's giving us the factors in the denominator. So hence we'll have to think of partial fractions there. And again, when we try and look into other rules, that's how I explained 3 rules. Can we try long division? No. Partial fractions, it does work. Functions are in the denominator in factors. And that's the method that we can take. If you wanted to use U method you apply it when you have functions in the numerator. That's the first thing. Or not even in the numerator, but in this type of algebraic functions, if it was in the numerator and you see that you have a function and a derivative in disguise, so you can try and use U method. And normally in functions which are in root form of, can say bracket to the power of n plus 1 or negative n minus 1. So only U method can apply when you see that, oh, I have a derivative of what is inside there. So you can try U method. But if you didn't have, you inspected the function when you derivate, you won't get what is outside the bracket, don't try it. So normally try U method when you see you're having a derivative and a function in disguise. Okay, I think I have explained enough there. We can move on with this one. Okay, so we are looking into the following, as I was saying. So what we're going to do, we must make sure that we have to solve for A and B. So please, when functions are changed, please don't be confused where you always used to X. I know that, so but just treat V as we know it's a function. Think about it, it's an X variable when you see velocity V there. So what we have to do, we must make sure, let's multiply out there, we'll have 2A. I want to multiply by the function there at the end. So it's 2V times A. And then A times 1. And we'll have plus B times V. So what we have to do, at least to see the function which is V, we need to make sure that we group those terms that have function V and the constant on the right hand side. On the left hand side, let's make sure if we had V here, we're going to make sure V is alone and constant. So but here we just have a constant on the left hand side. So here we just group the functions that the terms that have V, which is 2A and B. Factorize or take out the common factor of V. Therefore, plus this term here, which is a constant. Normally, you see I'll put in a bracket to show that I have the terms that consist of V and the constant. Now, what we're going to do, we're going to equate the coefficients of V on the right-hand side equals to the coefficients of V on the left-hand side. So on the left-hand side, we just have 0V, or we don't even see it there. So we're going to say now, not even let, we're going to say 0, it's equals to. Now the coefficient of V on the right-hand side, which is 2A plus B, that will be equation 1. With equation 2, we're going to say the constant on the left-hand side equals 2. So I think here I was supposed to put a note that equate. We need to equate here. Though when you're writing, you're not even supposed to write this. So we're equating here. So just don't think we're just dealing with the equations there. Equate coefficients of V, that is the first thing, and then followed now this step, we're equating the coefficients of the, or let's say we're equating the constants. So 1 will be equals to A. So we know that now A is equals to, already we have an answer. We have an answer already. So A is equals to 1. Now we need to solve for B. So solving for b, we'll substitute. So substitute a into equation 1. Someone says don't forget to like and subscribe. Right. So we have 0 in equation 1 into because you said a is 1, therefore plus b. Now b, it will be equals to, I'll struggle here today, I don't have a calculator. I wish I had an interactive one, if we're using Teams here. I'll struggle a bit with calculator with higher problems, but b will be equals to -2 then, because this is 2 times 1, take 2 to the other side, it will be -2. So we are done determining variable a and variable b. So we go back and state that for, if let's say we're integrating the following in terms of t is 100 then, which was 1 over v times in bracket 2v plus 1 dv. So if we have deduced into partial fractions, it is going to be equals to integral of, now this is like indefinite integrals from 0 to 100. For a, we stated that a is 1 all divided by v. We have to integrate in terms of v. So please make sure when you are now, after determining the variables, these was partial fractions. So now we remember we're trying to integrate that. So make sure that 1 over v integrated in terms of what? In terms of v. In terms of v. So these notations are very important. So in most of the tests, we noticed that you miss these variables. What is the notations? So please pay a note even into that. Right, but we have plus integral of 10, then upper limit 100. Therefore, b, we said, is -2, all divided by, and we'll have 2v plus 1 in terms of v. So, not to waste time, we know that integral of 1 over the function v there. So we know that it means we have is the function in the denominator and its derivative, which is 1. It came from ln or natural logarithm. Natural logarithm of the denominator there. So ln v. Let us not forget it's upper limit to upper limit 100. In fact, if we wanted to, should have done as a sum of functions there. Okay, someone is asking which question is this one? We're answering a 2025 July or August exam, July-August exam 2025. Question 5. Question 5. Let me do this. July 2025 exam. All right. So again, we need to integrate -2 over 2v plus 1. So normally, when you see quotient of function, the denominator set, we need to integrate. We look into the denominator. If I derivate this denominator, will I get the numerator? Yes, I can. Derivative of 2v plus 1, it will be +2. So this negative, it means that it was just a constant. So we have the derivative there, it will be derivative in a negative ln of the denominator. So negative ln of the denominator, because this is the derivative, this is the function. Or some, they will want to prefer to do it in this way, to say, I want to factor out the constant -2. And I want to be left with 1 over 2v plus 1 in terms of v. So some will want to prefer and do it in this way, that they want to inspect this, will it give me the derivative in the numerator? So derivative of this in terms of v will have 2. So we'll say there's a missing 2. So when you're done, you divide by 2. All in all, you'll always be left with -1 at the end. So you can say, oh, when I derivate this, I get 2. So it's fine. The negative there will always be there when we integrate. Ln v from lower limit to upper limit 100, so minus. So we know that is negative ln 2v plus 1. So even this we need to substitute from lower limit to upper limit 100 there. Or we can do it as a sum, we subtract these two. So as I said, because I know the missing constant, you'll say is 2, we divided by 2, that's why I have that. Or we can move from here, we know that derivative of this is 2. So when you're done, you can try and derivate this and see if you still get this. So when I derivate this, I'll have 1 over 2v multiplied by 2. So I'll still have -2 in the numerator. So, but though we're evaluating the following, what is it? Evaluating the following t. So we need to make sure we determine t there. I said I will struggle a bit. I think I can pause a bit. I want to look for a calculator, possible if I can find one. I left one at work. Okay, I did find a calculator, but to show all steps here, when we're substituting from upper limit, we now we'll have ln 100. I'm going to say minus, I think it's ln 10. Same thing with the other function. We substitute from upper limit, ln 2 times 100 plus 1. I won't have space here, but let me do a square bracket here and say minus from lower limit now, ln 2 times 10. 2 times 10 plus 1. We close that square bracket. So you'll write it nicely. So it's ln 2 times 100 plus 1 as we're substituting in this function. Therefore, minus the lower limit, ln 2 times 10 plus 1. Therefore, the solution is going to be equals to, I'll look into the first function, natural logarithmic of 100 minus ln 10. I'm getting around 2.024. Let me just say minus natural logarithmic of 2 times 100 plus 1. We'll have minus natural logarithmic of 2 times 10, which is 20, and plus 1. I think the following I'm getting a 2.5, or 2.2, 5, can I say 8, and 588. Let me say 88. Right, so the solution is going to be equals to, if it's 2.3024 minus 2.2588. Minus, did I minus correctly? Yeah, so I'm getting 0.04. I was going to say 44. into 3 decimals, so 0.436. Let's hope we are getting the same answer. I don't know, you'll confirm for me if the answer is incorrect. You will do so. I managed to get the glimpse of the question paper. I don't have the memo. Yeah, my coffee is cold now. Please grab yourself a coffee or Coke. All right, so let's try move on to. I said, let me try and monitor WhatsApps and see if you do have questions. Okay, it's quiet there. So yeah, you can you'll share or text on the chat if you do have questions. So, but please make sure when you're solving this type of questions, modeling definite integrals, you will now is not specific which rule you have to use, but make sure be realistic. Now, in the functions that you're given, you have to process fully. Is it partial? Is it long division? Am I going to use by parts? Am I going to do inverse trigonometric functions? Is it powers of trigonometry? For an example, all the rules in definite integrals will apply those. Sometimes even what we call Laplace transforms. So in those type of questions. So, but please recall all function rules of integration that you know when you are doing definite integrals, because you have to apply all the rules here. So your mind must be switched on. Okay, I hope I can shift these papers, or maybe I can leave one for now. Okay, it's out. So in the meantime, while we're moving forward to let's quickly do 5.2. Uh, 5.2. So 5.21, we need, right, we're given functions here. Y is equals to x squared. And the other one, y is equals to 2 minus x. So, and y equals to 2 minus x. We need to calculate the coordinates of the point of intersection of y equals to x squared and y equals to 2 minus x. So this is an easy one. So we know that we need to equate the two functions. So equating the two functions, that's where the functions will be equal to. So y is equals to y. Y of this function will be equals to y of the other function, x squared, which is equals to 2 minus x. So we know that at least if we have the higher degree of exponent, we can take this to the right-hand side. Gives us an idea of a quadratic equation. Taking x to the other side is positive. Taking 2 to the other side will be negative 2. We'll try and factorize if we can. Equals to 0. So we'll have x will be multiplied by x to get x squared. Factors of 2. When we add or subtract is 2 and 1. This must be positive. This must be minus. So negative 2 and then 2x minus x will be giving us x. So the factorization is correct. So therefore, we'll state that x is equals to minus 2 and or x is equals to 1. From there, we need to substitute in either of one of the functions to get to get the y values, because we need point of intersections. So I can say maybe sub x into y equals to 2 minus x into this function, the straight line one. So I know that if x is equals to -2, therefore y will be equals to, so it is 2 into minus in the function to -2. So y will be equals to, this will be positive 2, therefore y will be 4. And it means that for the point of intersection, the first one, this is point of intersection. So x is -2, y it is 4. The other one, if x is equals to 1, what will be y? Y will be equals to, so it's 2 minus into 1, then y will be equals to 1. So we know that the point of intersection, number 2, if x is 1, y will be 1. It's not clear here. Point of intersection number 2. Now x is 1, y is 1. So we are done answering that question for 3 marks. So just for 3 marks, just to get point of intersection. I'll remove this. 5.2.2. Now we need to make a neat sketch to show the enclosed area, the representative strip, and the points of intersection. So to be objective about this question, the enclosed area, by what? By the two curves. So it must be by the two curves in question 5.21. So we need to try and plot those functions. So not to waste time with the following function, according to me, I know that if the coefficient of x squared here is positive, the function must bend upwards. It must have a smiley face. If here it's positive, because I see it's just positive 1, it will bend upwards. What will be the 0 point, the y-intercept? It will pass through 0 because I don't have a constant for that function. And then don't stress much about the other values. You can just turn it there because it has to turn through 0. Just a rough sketch there. Then number 2, the straight line. If I'm looking at the straight line here, I have y. Let me use a different pen. So I have y, which is -x plus 2. So same thing with the straight line. I see that the gradient here, the gradient is negative. Therefore, the line must be, when I measure the angle of the x-axis, it must be greater than 90. But if it was positive, it will be bending, not bending, it will be bisecting in this direction, the straight line. The angle must be an acute angle. So, but this one, it must be, what is it? Angle greater than 90, obtuse angle. Now, we calculated point of intersection. They are very, they are useful now in our calculations. So we know the straight line must pass through certain point. If I can try and put and say this is 1, can I say 2, and then 3, 4, 1, 2, 3, can I say 4, maybe somewhere there, and then same thing, 1, 2, 3, 4, 2, 4. Okay, let me just even plot them down. So it's 1, 2, 3, and 4. -1, -2, -3, -4, -1, -2, -3, -4. 1, 2, 3, and 4. So point of intersection, if x is 1, y will be 1. So x is 1, let me do something like this. I'll say 1 is somewhere there. So it's a rough sketch. If x is negative 2, y will be positive 4. Somewhere there. My rough sketch. So therefore, what I'm going to do, I'll join the following points. So one of my graph, which is that one. So we have shown or drawn the enclosed area. So what I'm going to do, we know that we need to show the need sketch and show the enclosed area and the representative strip. So we know where the graphs are bisecting each other, it's here. Or maybe forming an enclosed area. So we need to shade that area there. Just shade that area with a pencil. So after shading the area, you need to put the strip in a way, especially in N5. Normally we use a strip that is touching either both of the graph in each and every point. So if we put the strip here, it must touch both graphs. At this point, it must touch the graph, this point, this point. So it means that we must put the strip in all or in every section that is touching both graphs. So please don't put it horizontally. Normally, if you put it horizontally, it will be touching one graph at some point, like here at the bottom. It will be touching the what we call the parabola. So I'm going to put a rectangular strip at that point to touch both graphs, the representative strip. So after putting the strip, we know that the thickness of the strip will be in terms of x, because the thickness here, it's in terms of x, but the height is in terms of y, the height. So it's y times dx. So after showing the point of intersection, we need to show them 1 is to 1. And this point here, it's negative 2 is to 4. So please make sure show this point of intersection. There's a mark for that, because the question said you must put the point of intersection. Number 2, making sure you show the enclosed area. It's very important, that's a mind. And showing the representative strip, it is very important. Number 2, to make sure you draw accurate, not accurate, but let me say approximately accurate graphs. So it is important, so that this will help you to calculate question 5.23, where we have to calculate the magnitude of the area in question 5.22. So you look into your formulations that we know that area under curves from lower limit, I was going to say for A to B. But when we look into the fluctuation of the area in terms of x, from the lower limit there, which is negative 2 to upper limit 1 there. So in terms of x, or thickness of the strip, it is fluctuating between negative 2 and positive 1. So we know that our lower limit is negative 2, upper limit is 1. Therefore, we know that we must put it in this way. It must be the top graph minus the bottom graph. We have to multiply the area. The area is the length times height, which is, did I say length? The height times the width, or the length times breadth, dx. So therefore, it is going to be equals to now negative 2 upper limit 1. Therefore, the top graph. So when we look into the top graph, the strip, it is a straight line graph. So we're going to say 2 minus x. In fact, put it in a bracket. It is subtracted by by the bottom graph. Bottom function, which is x squared there, is a parabola. And it must be in terms of x. And therefore now we need to simplify first before we integrate. Or if we want, you'll see that this is negative x squared, this is negative x, this is positive 2. So there's no need even maybe to subtract further, but other functions will need you to subtract. You can just integrate not to waste time. So I'll start with this is negative. Integrate at 1, it's going to be x cubed all divided by 3. And minus, this will be negative x squared all divided by 2. Then the constant, when you integrate, it will be positive now 2x. So that when you derivate, I must still get 2 there. Then from lower limit to upper limit 1. Okay, I'll pause there. Just want to get some thumbs up if we are still together. Challenge in the integration there. Okay, one is commenting. A second. All right. So we can, substitute now. In this section, it needs you to learn your skills to integrate. Number 2, to do substitution. It looks like it's very long, but it's not that long. You just need to pay attention. You'll see here when we start substituting, we'll have 1 over 3. I will substitute from upper limit, which is 1 to the power of 3, minus 1 to the power of 2, which is 1, plus 2 times 1. And therefore, we'll say minus, subtract the lower limit. Now that's where you'll see that I won't skip the to the power of 3 there, all divided by 3. And negative, in bracket, negative 2 to the power of 2. So pay attention even to the brackets, because if you don't put in a bracket, it will come out as a negative. All divided by 2. And plus 2 into negative 2. The last one is not clear, but this is negative 2 times negative 2. Right, so you'll confirm with your calculators there. I will have negative 1 over 3 minus half plus 2. Put it in units, 7 over 6. And the other one, I will be having negative into minus 2 to the power of 3, all divided by 3, minus into negative 2, all divided by 2, plus 2 into negative 2. So I'm getting negative 10 over 3. And the solution times negative 1. The solution for the following, I'll have 7 over 6. Adding there, I have 9 over 2 u squared. I have 9 over 2 u squared, or you can have 4.5. 4.5 units squared. So it's area, it's square units. We have square units. Please confirm them if you got the same answer. All right, thumbs up if we can move to the next question. But for bonus, please make sure you know how to calculate what we call area under these curves. So width, and what did I say? Area, volume. So just a bonus one, when you are going to calculate volume, it will be still the same one. You're just going to say -1, the lower limit, right? It was -2. Upper limit is 1. What we're going to do in your functions, the top graph -2x, it will be squared. The minus your lower graph, the bottom graph, all squared. In terms of what? In terms of x. Therefore, make sure, don't forget to multiply by pi. Pi by pi. So you just don't want to add more because the question didn't ask that. But this is what we'll do is pi r squared. It's pi r squared. So it's pi r squared. So the area, what we're going to have, or if we're going to rotate the area, normally when I explain to some, let's say it's that strip there. So when I rotate that strip, even this portion rotates. So it gives us a disk like. It gives us a disk there. So with the volumes, this is what you'll expect there. So that was the strip that, did I say the strip? Yeah, the strip that we have rotated about x-axis. Rotated about x-axis. So we would have something like that, a disk. So when I have a volume, the thickness here, we still know it is dx. And the radius, it will be from the inner part to the outer part. The outer part, it will be touching this inner part is smaller radius. So that's why when we want the area for that, it will be pi. When it comes to r, it will be r squared, which is touching the outer graph, minus small letter r, which is touching the inner graph. And therefore, pi r squared. So as we mentioned, for volume, it must be multiplied by thickness. It's no longer area plus the thickness. So volume of the disk. So its thickness multiplied by the base area of the disk. So I just wanted to add this as a bonus. Please don't forget the formula, but you'll put the limits -2 to upper limit 1 there. So this is just a bonus. So make sure you know how to calculate volume. So maybe a question can ask. So this one didn't ask that. But the tip, if you have managed to calculate area, limits are still the same. You're going to square your top graph, square the minus of the bottom graph. You will have a lot of terms there, mostly if so you must pay attention to simplification. Yeah, maybe thumbs up if someone did get that a bit. So just trying to explain something that you might expect. At least 2 thumbs up so we can move on. Super impossible. Thumbs up if we can continue in the next question. All right, we can move on. Thank you. All right, 5.3. Right, I hope maybe. No. All right, thank you for that question. Thank you for that question. I think it's James here. He's asking, is pi is it 180? But I understand you wanted to say 180 degrees. So pi, it is not equals to 180. Remember, in what is it? When you calculate area, what is it? Area of a cycle or volume of a, what is this thing? Of a, can I say a cylinder? The volume of a cylinder is pi r squared. It's pi r squared. So we have pi r squared. So it is just the one that you know the value. It will be 3 point something in commas. So please don't confuse it when you are working with trigonometry, because in trigonometry you will understand when you see pi, it means that it is measured in radians. It's only in trigonometry when you see pi, you know the measurement of the rotations is in degrees. So here we're just dealing with the area of a disk and the volume of a disk. So it's a volume of a disk. So you can just even Google it. What is the volume of a cylinder? Volume of a cylinder of a disk. So this is the simplest part that I wanted to start with it. So the test won't be crazy. So pi is not 180 degrees in volumes. I see someone is commenting. So this is the simplest section. You must take marks here. Take marks here. If you know how to integrate, you're sorted. Draw graphs, you're sorted. Right, 5.3, we need to calculate the moment of inertia. Calculate the moment of inertia of a uniform circular wheel of diameter 300 centimeter about an axis through its center and perpendicular to the wheel. The mass of the wheel is 50 kilograms. So please, in this section, you need even the formula sheets, but I'll try and go and look into that. So I'll explain two things in this question. I'll explain the circular disk and explain what we call rectangular shapes then. Right. So they said calculate the moment of inertia. What is moment of inertia? So moment of inertia, it's for an example, those who are doing civil will understand with beams or mechanical. So moment of inertia, we deal with the resistance of let's say, can I say a structure to resist what we call bending. So for an example, I wanted to take this calculator. For an example, if it's facing upwards, sometimes if I want to apply force there, it might break at some point here. If maybe let's say I hold on both sides, I want to break it. But if I put it in this format and I want to break the calculator, the rigidity will be more than when it is flat like this, when I'm breaking it in this axis. So we're talking about those type of things when we talk about moment of inertia, even second moment of area, about which point or which side the shape will resist what we call bending or to for it to a point of breaking. Excuse. So, but normally, just that I don't have a formula sheet here. So this one perpendicular to the through its center of axis. So normally we'll use IZ there because this normally the disk will measure through the Z axis. So you'll see that you'll see a lower limit. Can I say lower limits? Excuse. Lower limit A, upper limit B. So it must be R. It is the distance of reference from the point of reference, or let me say the distance from reference to the strip reference to. So you'll see that it will be R squared there, they multiplied by, here we talk about moment of inertia, So it's through the moment of the point of reference multiplied by change in mass there. So it's dm mass, this is mass there, section of mass. I want to look into the formula sheet. Where will you find that? I just want to confirm, where will you find that? I remember I printed this question paper, there's a formula sheet. Okay, so I think it will be the last section in your formula sheet. Formula sheet is given, you have volumes as I mentioned earlier there. In fact, it's there. So normally it's always measured about the x-axis. So normally we'll use this, the one we just did there. When it comes to second moment of area, it must be r squared moment of second moment of area. So there's two things. Second moment of area is r squared times change in area. And when it comes to moment of inertia, it is the point of from point of reference multiplied by change in mass. Change in mass. Normally you'll see this is rho, it's not p. It will be p rho multiplied by it's r squared times rho times v. So this is mass per unit volume. Rho is mass per unit volume. But normally stick to this, not to confuse yourself. So you have the formulas there. Don't stress yourself, use the formulas. Moment of area, moment of mass. So what I'm going to do, as we're given so what I want to do here, to some who have attended some of the lessons, they might have seen this. Just want to draw that disc there. It has its own thickness there. So similar to a volume of a disc that we just rotated. So we know that, for an example, here we have R, we must have R there, normal R. You can say normal R there. We use capital R. But what this is there for the disc there. What we want to do, what would cut a lot of strips, can I say a lot of sections of circular discs. So I'm just going to take a circular disc. Where's my pen? Just going to take one circular disc with its thickness there. So it's just that I want to draw it in 3D. So this just represents the axis Z there, because normally we measure by Z-axis. This is funny. But I wanted to talk about Z-axis because let's say it's X and Y if we use X and Y. But through center perpendicular to that disk, this is the Z-axis. This is the Z-axis. So in summary, what we are going to do. So I want us to agree that we will state that, for an example, this thickness here, it has its own area. So that's why we'll say this is dx there. So small thickness, it's like the disk we did cut there. And it will have its small radius from that point there to that. From point of reference to that point, it has its own radius there. So normally in summary, what we're going to do, I want to look into the bigger disk. If we're going to cut the bigger disk, let's say maybe from here to that point, and stretch it out. And when we stretch it out, for an example, it will give us a rectangular. It will give us a rectangular shape. If we cut here, normally, if you know about disks, not disk, about a cycle, if you cut it and stretch it out, you get that rectangular part. Can you rejoin it? You will have what you are interested in. So, and so what we're going to have, we will agree that here, for an example, as I was trying to cut, I want to show this part here, as we did cut there. So as we mentioned that the thickness of this dx there. So I'm looking at the smaller strip there. So what we're going to focus on, I want us to look into the perimeter of this. So when we look into the perimeter of from here to here, we'll understand that this is a perimeter of the disk there. So we know perimeter of a cycle, it must be 2 pi, must be 2 pi r. It's 2 pi r. So it's 2 pi multiplied by its radius. So for if let's say we wanted to look into the bigger one, we're going to say it is 2 pi, the capital R. 2 pi multiplied by the capital R. So what you need to know about this, when we are in moment of area, I wanted to moment of inertia, not area. If let's say we have mass for the big cycle there, or maybe let me say it's a rectangle now, the bigger cycle M, it will be equivalent to when we have the mass here, dm, I'll say changing mass for this strip here, for for that strip there. So what we need to understand, you must know that mass or the ratio of the following. So mass of the bigger, can I say triangle now? The rectangle, rectangle. It will be, we'll say directly, not directly, we'll say something like this. For the ratio M of the following, it's uniform throughout, similarly to the mass of the following. So we'll see that it must be uniform when it is divided by, what is this? The area of the bigger triangle there. So M over A. And therefore, for the smaller cycle, it must be dm, all divided by the change in area of the following year. So I'll say dA. Let me say dA, change in area. So for the bigger cycle, it will be its mass, it must be m over its area, equals to the ratio of the smaller, the change in mass of the strip that we have chosen over its change in area. So now what we need to find then, as you see according to the formula here. So I'm trying to establish dm. So dm is going to be equals to, so what we're going to do, we're going to have mass, which is multiplied by, because when I cross multiply by dA, by changing area there, all divided by the area of the bigger, can I say the bigger cycle or bigger rectangle. So therefore, to establish dm then, so we'll know that dm it is equals to, so we'll have m over, and we know that area of the bigger cycle, which is this, we know is given by pi r squared. It must be pi, the capital R, pi r squared. Therefore, dA, it is changing area for the following. So not to waste time, normally when you see dA, it must be the perimeter of the following multiplied by the thickness for the small one. So because you'll say length times breadth, 2 pi times dx. So you'll see you'll have 2 pi r multiplied by its thickness. And then, so if you have that, you can simplify and okay, so if we have the following, now we know that dm is equal to change in mass there. I want to establish something here. We can divide pi and pi, and we'll be left with m there. M all divided by r squared multiplied by 2. Can I say by 2r dx? 2r dx. And here, in fact, I was supposed to sort about that. So my dx here, because it's changing radius there, so I was supposed to use r there, but at the end I'll substitute, because this is my dr. I'm looking at my dr there. This is in terms of r, because it's not in terms of x. I'm used to the thickness in terms of x, so it's in terms of r there, the change in thickness and radius. So this is dr. Sorry about that. All right, so I want to substitute the values that were given to us. Must not lose that. So it was stated that the diameter d of the following, it is equals to 300 centimeter. Now, what will be the r of the bigger disk, or excuse, let's say from here to there, the r there, the radius, we need to find that r. We need to divide the following. By 2, because r from d, it will be 150 centimeter. And number 2, we're given a mass m, or mass of the, what is it, the mass of the flywheel, it is 500 kilograms. It's 500 kilograms. So therefore, I will want to substitute the mass here. So the mass, it is 500. So normally we know that we have to convert the units, because I'm looking at centimeter there. So please look into converting from centimeter. I think we have to divide by, is it 100 here or 10? I think by 100 to take it to meters. The meantime, let me substitute the mass is 500 kilograms, all divided by. So it will be 150 centimeter. That is the radius of the bigger disk r. Convert it to meters. So divide by 100, or is 10 to the power of negative 2. And therefore we have 2 r dr there. So we'll have this equals to. So we'll have 500 all divided by, I think it's 1.5. Okay, this is all squared, 1.5 all squared. Let me say times 2. So you'll confirm for me there, I'm getting 4,000 all divided by 9. I'll deal with it after. Then r times dr. R times dr. So now we need to determine, as we understand, we have to determine or calculate the moment of inertia. So what is moment of inertia? So is there in the formula sheet? Moment of inertia from point of reference there to the disk. The distance there is r squared. So when we're looking at the fluctuation of point of reference, so what I did, if let's say this was rotated through my point of axis to the point of reference there, I'll say this, maybe it's r there, because this is the diameter, or from here to the strip. So it's our point of reference. So you see it's from point 0. When we see that this from this point to that point, so the thickness of, not the thickness, or the change in r will range from 0 to 1.5, what we just did divided here, or from 0 to 150 centimeter. 0 to 150 centimeter. The range is between the two. The range is between them. So what we're going to do, we'll say that now moment of inertia, it is going to be equals to, we said from 0 point there, because that radius is measured from 0 to the tip of the following. Okay, thank you. Someone said it's 50 kg. Sorry, I saw 500. So it messed up everything now. Thank you about this. So it's 50 there. So I think I will have, if it's 50, I think this will be 400 over 9. It must be 400 over 9. Takes out 50 kilograms. 1.5 whole squared times 2. Yeah, it's 400. Yeah. Thank you for that. Immediately someone is paying attention. So let me convert to, as we said, I'm converting to what is it, to meters. So 0 to 1.5 meters. So because if you convert centimeter to meters, it's 1.5. 1.5. And therefore, it's stated that it must be r squared multiplied by dm. So we said dm, we just calculated now. dm, it's here now. Change in mass. Change in mass is this. So therefore, we substitute our change in mass, which is going to be 400 over 9 multiplied by r in terms of r. Therefore, the solution will be equals to, we're going to multiply out here. So I hope we see that we have from 0 to 1.5. I want to factor out this constant here, 400 over 9. Factor out 400 over 9. I see the like factors, and we have to integrate in terms of r. We'll have r cubed there. Excuse, r cubed. Integrate in terms of r. From there, straightforward, we have to apply integration there. So we'll have 400 all divided by 9. So let us integrate. We'll have r to the power of 4 all divided by 4. Then from 0 to 1.5. So from 0 to 1.5. Therefore, it will be equals to, I think we'll have to substitute the values here. We'll have minimal space, 400 over 9. So let's substitute. Normally, when you substitute 0, it goes out. With a disk, it's easier that way. So when you subtract from lower limit, it's out. So you just focus from 1.5 to the power of 4, all divided by 4. The other one is 0. Let me just put it there as a placement to see why did we get 0. Okay. So therefore, the solution for the following, I'm always dependent to students when it comes to calculators. So today it's on me. So 400 all divided by 9. So we have 1.5 to the power of 4 all divided by 4. So I got 225 over 4. I hope you can confirm there with your calculators. You can confirm for me. So, but all in all, if you have confirmed, so it must be 56.25. So as we spoke about mass, it is the point of reference times the change in mass. It's normally kilograms by meter squared. So that is moment of inertia. It's kilograms meter squared. Coming from its formula, it's the distance from point of reference all squared times change in mass. So mass is kilograms, the distance all squared. So which is 10 meters squared. Okay, someone got 225/4. Yeah, that's correct. Yeah, so that's when we deal with the moment of mass or moment of inertia. So with moment of area, you'll do the same thing, please. I know there's not enough time, but you'll reference to your formula sheet. This one is easier. You just say r squared times dA. What is dA? You'll just say 2 pi r dr. And then you integrate, that's all. It's not like this one, you have to manipulate a mass, but you can memorize this in this way. Mass of a bigger disk over mass of them, over area of a bigger disk. Then change in mass, the small disk over change in area, the small disk. So always when you deal with the disk, just look into this. It's 2 pi r times dr. So read the question. When always read moment of inertia and second moment of mass. It is moment of inertia. Second moment of area or moment of area. It talks about area only. Just deal with area. Don't deal with this. So it's because it's late. I don't want to add the rectangular strip. I wanted to add the rectangular one. But with the rectangular one, you deal with it in this way. The rectangular one, you deal with it this way. Is it all of in terms of x, or rotate the disk, the thickness, the strip in terms of y or x? You will check some problems there in the morning for this one. But I wanted us to manage to finish. The number is dropping here online. But I wanted us to finish question 5 and question 6. Maybe we can try question 4 if you are still fresh. I think we're done with question 5. I just lost question papers. Oh, I found it. Yeah, we're done with question 5, I see. So all 19 marks was for you for grabs in this way. If they added volumes, it might go to 25 or 24. Okay, I'll try to save this video if you have time, but it will be long. You can release it again. Okay, let's look into, if you allow me to remove, let's look into question 6 then. Yes, this is an interesting question. It's an interesting one. And it's very easy if you start analyzing it. That's how you apply maths now. The design of shafts, you will definitely pass. That's how we design shafts and the beams here. Normally, even when we go to electrical, when it comes to when we talk about the wires, the copper inside there, you can know the uniform area. It will be uniformly with the change in area inside the copper. Okay, okay, at least I see the interest here. I think I want us to check question, what do we call this? Question 6. Okay, where is my question 6? Okay, I found it. So question 6 was very short, but it has 8 marks. Yeah, it was very short. So when we look into question 6, looking into 6.1, we need to determine the general solution of general solution. So general solution, here we are in differential equations. We're in differential equations. In N5, we only deal with the separations of variables where possible, or make sure that functions are integrated implicitly so. So we don't do the homogeneous, what we call this, not to confuse you, but in N6 you'll do more of this type of differential equations. Okay, particular solution of the following. So we have x squared 2y cubed minus y. So we need to determine the general solution. So what we have to do, we need to make sure that it comes from, I can give an example of implicit functions, with implicit functions. So when we think of implicit functions, you'll remember that you were derivating functions, sometimes even applying what do you call this, product rule in between them. But here you must make sure that when you're integrating, let's say your right hand side, you must integrate in terms of one variable, your left hand side in terms of one variable. So here we could integrate and say derivative of this, or it came from y. But in the following, we have y, we have x in the midst of the following functions. It means we have to simplify or do separations of variables there. So how will we do that? So we need to make sure that we inspect what can we do so that the following functions look alike, or we must make sure y is on the other side is integrated in terms of y. So what I'm going to do is to try and simplify the following, or if you didn't want, you can try and make sure you take the other variables which are in terms of y. So if I'm looking into this, I'm going to multiply on both sides of the function by only factor 2y cubed minus y, by only factor 2y cubed minus y. So when I multiply, let me use a different color. When I multiply, don't have space here. Okay, let me just multiply here. I'll fix it after. I'll have 2y cubed minus y. I want to do separations of variables. And I see y here, y to the power of 5, it's multiplying. So I'm going to divide by y to the power of 5 on both sides of the function. So here it's divided while this was multiplying. Therefore, it will be equals to, on the right hand side, we want to be left with x minus 1. We're still dividing by x to the power of 2. What I'm going to do, it was dy over dx. I'll multiply by dx on both sides. So I'll have dx on the right hand side. If I have multiplied by dx here, it is divided, and I have it on the right hand side. Okay, I hope it's clear. And now moving to the second part. So you can integrate the following if functions while they're not fully simplified out. So the idea that I'll see that according to laws of fractions, these two terms, they're sharing this denominator here. So I can divide 2y to the power of 3 by y to the power of 5. Allow me to write this factor in front here. So if I eliminate y to the power of 3 here, I'll be left with 2 over y to the power of, if I subtract the exponent, to the power of 2. Therefore, minus y is eliminated here, I will be left with 1 over y to the power of 4. Therefore, still multiply by dy. Right, on the right hand side, same thing, the loss of fractions, these numerator terms, they share this denominator. So I split accordingly, x divided by that, it will be 1 over x, 1 over x squared, it will be negative 1 over x squared in terms of x. So I've done separations of variables here, so we can state that we need to integrate the following in terms of x and y on the left hand side. But again, the functions, before you even integrate, they must resemble something that you have derivated. So I'm going to do this now, introducing an integral side. I want to integrate the following. So when I'm looking, this is y to the power of 2. So it's a function and a constant. So y, I can take it to the numerator to apply power rule. It's y to the power of negative 2. Therefore, minus y to the power of negative 4. Therefore, we have to integrate in terms of y. The right-hand side, so 1 over x, there's no need to do to simplify that, because it must not, if we want to use power rule, x must not be a negative 1. So it remains in the denominator, because we know this came from ln x. By the following, where the exponent is greater, I take it to the numerator, which is going to be integrate in terms of x there, which is going to, this one is going to be x to the power of negative 2. Integrate in terms of x. Right, so when we have the following, I know, okay, the first term I'll use power rule in terms of y. So I'm going to add 1. When you add 1, it's going to be negative 1. Please divide by that negative 1. Though this, I wanted to write it as negative 2 over y. This step is not necessary though. And we have negative y to the power of negative 3. We add 1. If we have added 1, so divide by that exponent, negative 3. Therefore, is equals to integral of 1 over x. It is ln x. Now, integral of the following, we add 1, it will be to the power of negative 1. Divide by that negative 1. So if you want, you can add the constant on the right-hand side. For a general solution, add the constant. Now, what we're going to do in the following, we just simplify and leave it as it is, as positive exponent. So I'll have negative 2 over positive y now. And I'll have positive 1 over 3 y to the power of positive 3, taking this to the denominator to make 3 positive y. Therefore, ln x. So the following will be positive 1 over x plus the constant. So if you want, you can leave your answer in that format. Leave your answer in that format. There's no need to do simplification there. Okay. So that is general solution. That is general solution. Question 6.1. Okay, I'll pause a bit and a thumbs up for us to continue 6.2. Oh, must drink water. Say y is there, mod plus c on the y side. Okay, so normally we can only, can I say that? Not only one constant. Yeah, but I can state it in that way. Normally, we can either have one constant because we can add the values of a constant to give us one constant. So this complements, if let's say we had 2 this side, here we had 1. So okay, we could even take 1 to the other side to give us 2 minus 1 to have 1. So which means we can always have one value of the constant. That's why we can put it on this side or on the other side. Okay, I hope that answered the question. So that is differential equations. So finding general solution. So here we'll even apply other rules that we know when it comes to what we call integrating here at some point here. Okay, looking into, yeah, the energy is dropping on my side, but let's wrap up that 6.2. Okay, I think the 6.2 to save space, let me just put it here, 6.2. So we need to determine the particular solution of, when we're given d squared y dx squared minus 9x minus 12 sine, let me put it here, minus 12 sine 3x equals to 0. So it is stated that with dy over dx, which is equals to 2, and y it is equals to 1, at x is equals to 0. At x is equals to 0. Determine the particular solution of d squared y dx squared minus 9x minus 12 sine 3x equals to 0, with dy over dx is equals to 2 and y equals to 1 at x equals to 0. Okay, so solution for the following. So still the similar thing, we see we are dealing with differential equations here. Now we call this is a second order. Why is this a second order differential equations? Because it means that the function was derivated twice. Yeah. Or we can say it was derivated twice. The first one, or the initial one we had, it was a first order because it was just d over dx, so it was derivated once. So even in second order, we can do separations of variables. We must make sure one side is in terms of x, the one side is in terms of, let's say, d over dx or y. So what I see with this one is straightforward. We have d squared y over dx squared. What we have to do, we must make sure, as we know, that one side must be in terms of x. I'm going to take 9x to the other side, it's going to be positive, and then positive 12 sine 3x. Okay, I hope you see on the following function, the right hand side is in terms of x, the left hand side is the function derivated twice. So it shows that the function in terms of y was derivated twice. To find a what we call particular solution, we even have to determine the xz values or even the constants when we're even given the following. So what we're going to do, there's no need of even putting an integral sign and multiply by dx on both sides. There's no need, because we know why here was derivated twice. So let us integrate. So where does, I can put it in simple terms for students. What did we derive to get the function for the second term? So we want to get it for the first term. We know we derivated dy over dx to get d squared y. So that's why when you integrate, we go back to dy over dx. And on the right hand side, we know applying the rules, it will be 9 we add 1, all divided by 2. Therefore, plus. Integral of sine, it is very key there. We know it was supposed to be, we are supposed to have negative here because derivative of cos is supposed to give us negative sine. So we know we must have negative, let me say 12 cos 3x, because integral of that, of this function is cos 3x. Please don't forget to divide by the derivative of the angle, which is 3 then. Or if you wanted, you could have split this to be 3 times 4. So you'll know that, oh, 3 is the derivative, and then 4 is a constant. You're going to say 4 cos 3x. So we're going to say plus. It's either you can put A or you can put C1. It's a constant. A, they represent constant. We can say C1 or we can say A. Now, we need to or sum the integrate further, but we are given, we need to determine now A there, the constant now. It is given to us that the y over the x is equals to 2 and y is equals to 1 at x equals to 0. So it can help us to determine the constant there. So we know the y over the x is 2. Therefore, x is 0. So x is 0 at y is equals to 1. So here we don't have y, we just substitute in that case. 12 cos 3 into 0, all divided by 3. But this is 4 here. This was supposed to be 4. Plus A. Plus A. So not to waste time, we have 2 is equals to. You will help me out. We know that cos at 0, it's 1, isn't it? So here we'll have negative 4. Because this is 0, negative 12 divided by 3, it is negative 4. So cos at 0, we have 1. So 1 times 4, we have negative that. Therefore, plus A. So now we can determine the constant. A, it is equals to. Take 4 to the other side, it will be 2 plus 4. We will have 6. Now from here, we are going to now substitute now back the constant to the function we integrated. Where is it here? That our dy over dx, it is equals to, what is this? I think it's 3.5 over 2 x squared. This we said is minus 4 cos 3x. Now plus A, we said it is 6, so we put our 6 there. Okay, someone is asking why do we substitute 0? We are substituting the values that are given. If the y over the x is 2, then y is 1 at x equals to 0. So where there is x, we substituted 0 in the function. We substituted 0 in the function because x is equals to 0. That's why we substitute 0, and we substitute 0 there. So that's why we got 6 there, because this goes to 0, this going to negative 4. dy over the x, dy over the x is 2. Okay, I hope it is clear. We're substituting values of x there. Okay, so in that case, we need to determine the particular solution. And here we are still having the first derivative. So we need to integrate further to find the, or can I say, original function. dy over dx. What did we derivate to get dy over dx? We know we derivated y in terms of x to get dy over dx. So we integrated, we have 1. Then integrate the following. So we're going to have x to the power of 3. Let's divide 9 over 2 by 3. I hope you see that. I think it goes 3 times 3 over 2. So x to the power of 3, we have integrated 3, so divide the constant by 3. It's 3 over 2. And therefore, minus integral of the following function. It will be still 4. Integral of a cosine function, it must be sine 3x. Let us not forget to divide by the derivative of the angle, the missing constant. 3 there, therefore plus integral of a constant 6, it must be 6x. Therefore plus, let's put another variable, you can say c or you can put b. It's a constant there, there's no x. So in that case, we can now determine what is it? Let me not waste time. We can determine the variable b there. So we are given that y equals to 1, then x equals to 0. So where there is y, we're going to substitute to 1. So we have 1 equals to 3 over 2x is 0. We know that. Minus 4 sine 3 into 0, all divided by 3, plus the constant b there. So therefore we need to simplify. What is b? B is equals to, we will agree that b is equals to 1. Because this goes to 0, sine is 0, it's 0, 0 times that goes to 0, plus b. So b is equals to 1. So therefore we can conclude that therefore the particular solution, I always call it PS. The particular solution, y it is equals to 3 over 2 x cubed minus 4 over 3 sine 3x plus 6x. B we just calculated, now it is equals to 1. So therefore our particular solution, our PS there, that is 3 over 2 x cubed minus 4 over 3 sine 3x plus 6x plus 1. So that is the final solution for 6.2 then. All right, it's not yet 12. I'll see thumbs up if you will want to go to question 4, or we can break from here. We'll hope to get time the next day. I don't know. So thumbs up if we continue, or we can write that we can rest for tomorrow. Okay, any questions, clarities, confirmation? Should we continue or should we break for today? All right. Oh, someone is going to sleep. Good night, guys. And some, what are you saying? At least we need a second if we're sleeping. Oh, we're continuing. Let me see. How long can it take us for question 4? It can take us 30 minutes. Or 25. Super impossible. Vanilla. Okay, thumbs up that we're continuing. One said we're sleeping. Yeah, people are still fresh here. We already took 15 Red Bulls, huh? Okay, so can we please continue and can we do a different question paper tomorrow if possible? Yeah, if I have time, tomorrow we'll try and do another question paper. But with me, I'm interested in you understanding concepts. That's why you hear me over explaining in one question that don't look into it. You will have time. Yes, Manera, you will have time. So that's why I'm saying that I understand the theory, then, or let's say, let me not say theory, the concept, then cramming question papers, it won't help much. So that's why I over-explain in one problem that you must understand it in this dynamics or direction. So it's very easy if you understand concepts in all the questions. But make sure you understand your formula sheet. We can do another question paper. It's not a problem tomorrow. It's not a problem. But okay, let's try that question 4. I think question 4 can conclude by it, and we can look into what will be the question following. I think it will be question 2 or question 3. Yeah, question 3 is very long. So today I don't think we'll manage to do. Yeah, let's look into question 4 only. Yeah. So I can rest. I have a long day tomorrow. Okay, let me do the following. In question 4. Please forgive my handwriting, but I know some of you are used to the handwriting by now. So we were given y is equals to 2x minus 1, all divided by 2x squared minus 2x. Okay, sorry about that. I must have plus 5 here. It looks funny. So sorry about that. It's plus 5 there. So we need to determine the integral of y in terms of x in each of the following cases. We need to integrate the following. So it's not easy to tip exactly when you solve problems, but you need to think in 3D. First of all, you see, the first thing you inspect, you see you have quotient of two functions, or quotients of functions. That's number one. Number two, try and inspect with C. More normally, when you have quotient of functions, I always say check the denominator. If when you derivate the whole denominator, are you going to get this, the numerator, so that you can think of the rule of f prime of x. Normally, I refer to this formula when you have f prime of x all divided by f of x, so that you can state that, oh, this is ln of the denominator. That is the rule plus C. When you have quotients, I always refer you to that. But then if you inspect the whole function when you derivate, I hope you see there's a square there, and you're supposed to have this repeated there, and it means that this is not the derivative of this. So you can move on and inspect now. And please do not be tempted by partial fractions, because this whole function here, it's all squared. But if you could factorize and split, you could try partial fractions if it can work. But you can see normally we focus on dealing with just factorizing factors there. So which means it still doesn't work out partial fractions. And don't think of long division, because the degree of exponent is not greater in the numerator. So if the two now they're not working, you think, oh, but I see something which is inside the bracket there. When I derivate 2x squared minus 2x, it gives me an idea of what I do. I'm looking at there. Because if I was going to close 2 there, I was going to get 2x there. When I derivate x, I was going to get negative 1. Therefore, 5 is out. So it means that what I'm having there, this is the derivative. This is the function inside the bracket. So you have to rewrite it in this way before even use U substitution. That if I integrate, I have to integrate the following in terms of x. I take the denominator to the numerator, which is 2x squared plus 2x plus 5. Now it's going to be minus 2. Integrate in terms of x. So it gives an idea, okay, now of the chains of functions then. Because I see what I have here, this is 4, this is 2. It means the common factor which is missing here, is the constant here is 2. So you can even use inspection method. Just add 1 here and divide by the exponent that you have added 1 on. But let me write this to show you that you must think of now, according to this rule, f prime of x multiplied by, this is a bracket, f of x all in all to the power of n in terms of x. So I know according to this rule, I love y, it will be f of x all in all to the power of n plus 1 all divided by n plus 1. So this is the rule when you have product of functions. You inspect if you have the derivative and if you have a function inside the bracket. That's when you can add 1 into the bracket and divide by the exponent. Because remember, in derivatives, you multiply by the exponent, subtract 1, and multiply by the derivative outside of this function in derivatives. So I was re-explaining so that you can understand when you inspect functions, don't just integrate. Think of all the possible solutions, or where does the function come from. And the rules must complement your simplification or your process of solving the problem. So I know normally you are used to let u to be equals to the function which is inside the bracket, not the whole bracket, which is going to be 2x squared plus 2x plus 5. Now we are going to now derivate the following function in terms of x, du over dx. Let's derivate this. We have 4x plus what? I even changed the function here, sorry, allow me. So it's -2. It's -2. This is -2. So I'll have -2 there. Therefore, I said always multiply by dx on the other side, because it's du over dx, multiply the right-hand side by dx. So we have 4x minus 2, derivative of 5 is 0. So now number 2, we need to solve for x now, solve for dx to say. So you're going to divide by this on both sides of the function. But always know that when you are dealing with functions, utilizing your substitution, you need to cancel out something. Let me use the word cancel, but divide them. So let me divide du by the following function. But I see there's a common factor there, which is 2 on this when I divide on both sides, because there's a common factor of 2, I will be left with 2x. Common factor I've taken out, which is 2, I'm left with -1. We re-multiply, still have 4x minus 2, which has divided du there. Now we're done. We can state that from that we come there. So when we integrate our function, we'll have 2x minus 1. And therefore, we'll have 2, can I utilize u? So it's u to the power of -2, because we are replacing the function there, which was in terms of x, to be in terms of u. So u, we said, is equals to the following function inside there. So u to the power of -2 multiplied by dx. Dx, we said it is equals to du all divided by 2 into 2x minus 1. From there, I hope you see the idea now that 2x will be divided by 2x. We'll be left with 1 over 2, this 1 over 2, because 2 is dividing there. So we'll be left with 1 over 2. This, it is u to the power of -2. Therefore, we have to integrate in terms of u. We left with u and u to the power of -2. So therefore, now our solution is going to be equals to, it's a power rule here now. We're going to say u to the power of -1 all divided by -1. You can add the constant there plus c. So though we're not integrating in terms of what is it, the function originally, it was in terms of x, we need to replace or substitute back. But please take this to the denominator, it will be u to the power of +1. So I hope you see we'll have 1 over 2, then u to the power of 1. U, it is equals to 2x squared minus 2x plus 5, all in all to the power of 1. Therefore, plus the constant. We're done integrating 4.11, utilizing u substitution. But to those who understand inspection, just let what is inside the bracket to be equals to f of x, and specify that f of x is this, then f prime of x is this. So therefore, the only thing which was missing, it was 2 here. So we're just going to add 1, it will be -1, divide by -1. So that's why we still have that negative here. So it's -half times 1 over that. Okay. I hope it's clear when it comes to, I think this was chains of functions. We don't see the roots there. But if normally we have roots, please remember function and the derivative in disguise, where you even have to solve for x in those type of problems. Okay, thumbs up if we are still together. Okay, someone is wrap for me, sir, and sleep is for the week. So can we please continue and we can do different question paper tomorrow. 6 minutes to go. Okay, thumbs up if we're moving forward. So 4.1.2, we have to integrate sine to the power of 5 x cos to the power of 3x cos to the power of 3, then angle x dx. Right, I hope we can continue. Vinny. Like react something so that I can continue 712. All right, so yeah, okay, we're almost there. Okay, in the following, in some of the tests for trimester 2 when I inspected, when it comes to different coefficients of, thank you for the reactions there. When it comes to what we call different powers of cosine and sine, or it can be cosine and cosine. Now, in fact, before I even go further, but when you see different powers of cosine and sine, we have to choose one that we can deduce the exponent to be at least to the power of 1. But normally we have to choose the one which is having a lower exponent. Normally we always choose there. If we have odd and odd, we choose the lowest exponent. If we had odd and even, we'll always choose the odd one to simplify our problem. But if they were both even, we're going to try and utilize double angle identities. We're going to use double angle identities if they were both even. So we're going to try and simplify and have double angle identities. So if they're both even, we just have to change one here, at least to have a cos to the power of 1. Because even if you want to say this is the function, this is a derivative, it's not true. If we derivate sine, we cannot get cos to the power of 3. Or even when we derivate cos, you cannot get sine to the power of 5. So we cannot think of the formula earlier that I mentioned of f of x times f prime of x. So to make it to look in that way, to look in that format, we are going to only simplify one x function that is having an odd exponent, at least the lower value. So we're going to say that here we're going to have cos to the power of 1 multiplied by cos to the power of 2. We are using exponential laws at least to deduce the exponent to different powers, at least 1 to the power of 1. And from there, we want to have that idea of having a function multiplied by its derivative. So we have y, which is equals to, we have sine to the power of 5. What we're going to do, we're going to change cos squared there using the square identity, where we're going to have 1 now minus. We know cos squared is 1 minus sine squared in terms of x there. So therefore, we're going to now, this is a bracket. We need to take out the bracket. So normally we'll see this function multiplying 1 and integrate it in terms of x. So it is sine to the power of 5 multiplied by cos x. Let's multiply by dx2. And therefore we have this times that. So the negative multiplies, we'll have So it was going to be difference of functions. So when you multiply sine to the power of 5 times sine to the power of 2, it will be sine to the power of 7, then angle x, then times cos x there. Then we multiply by dx2 because dx multiplies these two terms there. So I hope you see it gives us the idea. I hope if we can close the exponent, when you derivate sine, you can get cos there. And we know we can get cos. Derivate sine, we can get cosine. So it means that the function inside the bracket to the power of 5, the function inside the bracket to the power of 5, because treat it as in this way, as sine to the power of 5, multiplying cos there. So I know that when I derivate sine, I get cosine there. So I can just add 1 and divide it by that exponent, I've added 1. Or some, when they want to choose a longer road, this is longer, I won't advise, but if you have inspected, you can just add 1. You are going to have 6 over a sine to the power of 6 divided by 6. But some want to say that I see that when I derivate this, I get that. They will say let u to be equals to sine x. But though this is a longer road, in this type of problems, I wouldn't advise. Except if it's more complicated, you can use u. All right, derivative of sine x, I know is going to be positive cos x. So multiply on both sides by dx. And we know that dx is going to be equals to divide by cosine on both sides. It will be du over cos x. And therefore, in that case, in our function there, in both functions, you can say that you said u is equals to sine x. So you say this is u to the power of 5. Therefore, multiply by cos x. Dx, we said it is du over cos x. Therefore, minus. In the same function, we said sine x, it is u, we'll say to the power of 7, multiplied by cos x. And then dx specified here or calculated, it is cos du over cos x. So our solution is going to be equals to now. While we're still simplifying cos x, I hope you see it is divided by cos x. So we are having u to the power of 5 in terms of u minus, same thing, cos x is divided on the other side. We'll have u to the power of 7 in terms of u now, variable u. So it gives us a power rule. Normally when you use u substitution, it must at least give you power rule there, just one function. So hope you see we'll have u to the power of 6 all divided by 6. And therefore minus u to the power of 8 all divided by 8, now plus the constant. Please substitute back the function. You said it's equals to u. So we know that u is equals to sine x, all in all to the power of 6, all divided by 6. Minus sine to the power of 8, all divided by 8, plus the constant. So I hope you see that just to go this longer route of letting you, if you have inspected here, to say that, oh, I have a function inside, the derivative of that is cos. So you're just going to add and have 6 all divided by 6 on side. Same thing with this, you're going to say to the power of 8 divided by 8. Because I see this is a function, this is a function, this is a derivative. So, but if you want to be sure is when you have constants, not constant, the coefficients of the angles. Maybe it's 2 there, so you can try and use u substitute to complement the constants. If not, you just be smart and not wasting time and move from here to this. Right, I hope we still have the energy there. Yeah, and all these problems are longer. Thumbs up if we can continue 4.13. Or is that time of the night where your grandmothers visit you at night? Or is the angels of God? Or it's time to pray? Okay, any comments and a thumbs up if you can continue? Hey, people. Okay, yeah, Carlos says we can continue. Second that Vinyakalo. Okay. All right, let me gain strength here. I think we have to continue 4.13. We need to integrate the following. This 2x to the power of 4 plus x cubed plus x squared minus 2, all divided by 2x plus 3 dx. We need to integrate the following: 2x to the power of 4 plus x cubed plus x squared minus 2, all divided by 2x plus 3. Okay, we inspect. Always inspection is very important here. So I have quotients of functions. That's the first thing that I see. Number 2 is algebraic functions. It's easier now, it's better. All right, so it's algebra. 1 is dividing. Do I, even if I wanted to say this, can it give me the numerator as a derivative? No. But not to waste time, that I see the degree of exponent is greater in the numerator. So henceforth, it takes me to long division now. Takes us to long division. So according to long division, is it going to fit here? Okay, try and make it fit. We're going to take the dividend, which is 2x to the power 4 plus x cubed plus x squared minus 2. So we are going to take it to inside, to be inside the division. And then now the divisor, we put it outside, is 2x plus 3 inside the root there. So always when I talk about sequence of long division, we divide, we subtract, and no, not we subtract, we multiply. I'm tired now. And we subtract. So that is the sequence: divide, multiply, subtract. I was trying to read the comments there. Someone says also don't have the crown. Which crown is that? So why don't I have a crown and others have a crown? I don't know. Maybe it's because they're the most followers. They watch most of the videos there. They always maybe watch most of the videos. The number one viewers here. So maybe if you want to take over, just comment, keep on liking most of the videos there. Maybe we can get goodies after when we do the selection of prize winners of the most participant. Okay, I know. Okay, I hope we can continue. I hope we can continue. Yeah, but yeah, what Vinil mentioned, are you guys are not participating in us? Maybe those with crowns are the ones with distinctions. Yeah, maybe it can be true. But normally those who participate more in the charts and reacting and everything, they are more well recognized there. Yeah, so I think I must get the names of Vinyl and Super Impossible. And who is number one there? Oh, it's Super Impossible. So who is number one? Number two. Who is number two? Number two left. It was who now? It was Montex. Montex was reacting. Right, let's not waste time. Let's continue. So the sequence of long division. Sequence of long division. We need to divide. First of all, always divide the first term of the, can I say dividend, by the divisor. So it's 2x to the power of 4 divided by 2x. So I'm just showing you that normally you'll do it in this way. Though it's not allowed to write this. And the answer that you get, you'll always put it on top of the division. So it's 2x to the power of 4 divided by 2x. So the answer that we get there, I'll have x cubed. When we're done again, the sequence, as we said, is divide, multiply. I'll remultiply the whole divisor by the answer there. X cubed times 2x, it will be 2x to the power of 4. X cubed times 3, it will be plus 3x cubed. So what we're going to do, draw a line. We want to subtract now. So the one who put, we'll say minus. I want to minus this whole expression from the top one. So hence we'll start saying 2x to the power of 4 minus 2x to the power of 4 is 0. And x cubed minus 3x. So now this is minus 3x squared with x cubed to say. We'll have negative 2x cubed. And therefore, if you can say x squared, or you can drop down these terms, they don't have like terms. You'll have plus x squared minus 2. So the sequence is going to start again. We repeat the sequence now. We need to divide until we have a constant or either a 0, a remainder of constant or 0. So we're going to start again. The first term of this remainder here must be divided by the first term of the divisor there. So it's going to be 2x cubed. Or maybe I must do the same thing again. But though this is not allowed to be, I'm not supposed to show this. 2x cubed all divided by 2x. And the answer that you get, going to write on top of the division. Going to write on top of the division and multiply again. All right, so let me divide negative 2x cubed divided by 2x squared. I'm going to get positive now. It will be positive, okay, x squared. So this divided by 2x is positive 2x. Negative, sorry, is negative So this divided by 2x, I got negative x squared. So negative x squared, by that, I'm going to have a negative 2x squared. And negative 2x squared times the 3, did I say negative? So it's going to be negative x squared. So the one who draw can I say a remainder line. Let me do a remainder line. Let's subtract this expression from this top one now. So we're going to say negative 2x cubed plus 2x cubed plus 2x cubed. So this is cubed here. I hope it's clear. So negative 2x cubed plus 2x cubed is 0. Always the first term must be eliminated. And x squared plus 3. This is plus 3 now because negative and negative is positive. So plus 3 plus x squared, it will be 4x squared. So negative 2 doesn't have like term, you just drop it down, or you say negative 2 minus 0, it is negative 2. So we still have a remainder of function there in the new, let me say the numerator. We must have a constant or either 0. We repeat again. So we're going to say this divided by the first term of the divisor. So it's going to be 4x squared divided by 2x. So I'll have plus 2x. And 2x times 2x, we must have 4x squared. 2x times 3 will have 6x. So we'll draw a remainder line. We want to subtract the following function. So 4x squared minus 4x squared, 0. And I hope you see that here we don't have x here. So that's why this will be negative 6. So it will be like 0x minus 6x, which will have negative 6x. Negative 2 doesn't have like term. We'll still have negative 2. Because this became negative, it was subtracting the top expression is negative 6, still minus 2. So we still have to divide, we are not done, because this, we still have a function, not a constant. So for the last time we divide, so negative 6x divided by 2x. So we're going to have negative 3, because 6 divided by 2 is negative 3. So we're going to say negative 3 times 2x, we'll have negative 6x, negative 3 multiplied by 3. We'll have negative, it's 9, 3 times 3 is 9. Draw a remainder line, we need to subtract the following function. So if we have negative 6x plus 6x, it goes to 0. And negative 2 plus 9, so this plus 9. So I think we're going to get 7. So it goes positive 7, positive 9 plus negative 2, 7. Now we can conclude because we have a constant now. Because we can't continue dividing further by this, we'll be having 2x in the denominator. So we can conclude the answer. That therefore, after dissolving the function into using long division, the answer will be equals to, put the integral sign. Therefore, in bracket, the answer that we got, let me just do this. We got x cubed minus x squared plus 2x minus 3. What is the remainder? We got positive 7. Or we can still divide further by 2x plus 3. But we concluded that the answer, the last term can be divided further by 2x plus 3. So that is the solution. So therefore now if it is using long division, it is being divided, we can integrate now. So where we're going to have x to the power of 4 all divided by 3. These, I think, is going to be negative x to the power 3. Sorry, this is over 4, tired. All divided by 3. And the following, we're going to have plus. We're going to have x squared. So divide 2 by 2, that's why we have 1 here, because x squared divided by 2 divided by 2, we have 1. Therefore, we have negative 3x. Therefore, plus. This is critical and key. In long division, you'll have functions that you'll have to use ln of the denominator. But if I inspect the following, when I derivate the denominator, I was supposed to get 2 in the numerator. So there's a missing constant 2 there. So we have to divide by that constant 2 when we're done. And only you can divide by constants, not functions. When I inspect this, it was supposed to give me constant 2. So as we know that it's 7 ln of the denominator 2x plus 3. Okay, it's not clear, but we must divide by constant 2, the one which is missing. So it's 2x plus 3, 2x plus 3. Or let me cancel it out here and just put it here. We're supposed to have 7 over 2 ln 2x plus 3. This is the last term here. So try to make it look ugly. So there it is. So please always pay attention when you're dealing with natural logarithmic integration that the function must be complemented when you check their constants there. So there was missing 2 there. So that's why we always divide by the constant that is missing. Right, I hope it's clear. I see retracting messages. Okay, that's long division. I hope it's clear for Karabo. Vinny. Vinny. Super impossible. Still here. Thumbs up if we can wrap up 4.1.4. Okay, 2 more to go for question 4. Let me put it like 2. Okay, 2 commenting. Okay. Okay, at least, all right. Yeah, so that's long division. I always say partial fractions and long divisions, the easiest unit that you can take marks from. Just need to pay attention on when you are simplifying, especially in the division. And most of some of the tests, I saw people losing. According to science here, normally, I hope you saw I was putting a bracket when I'm subtracting, so that you understand it. The negative influences the terms that you just multiplied them. So, okay, let me see the last. which one is it? Oh, it's 4.1.4. We have to integrate x multiplied by log 4x to the base 3. All right, so same thing, inspection is very important. We have product of two functions here. We have a linear function multiplied by a logarithmic function. Now, by applying inspection, hope you see that even if we wanted to say, can this log, when we derivate, can we get x? Nope. And we know x, when we derivate, we can't get a log of the function. So now it takes us to those product of two functions. Product of two functions, it's either we'll think of by parts or the chain rule there. So which means we are going to try and utilize what we call by parts. So we need to try by parts. So in by parts, normally I always say that people must just utilize the sequence here. I always say it's ilate. So to those who speak Southern Sotho, they will understand ilate, you won't forget. So this in the sequence of choosing f of x. You must start choosing f of x if you have inverse trig functions. These are inverse trig functions. Or between the two, you can choose either one of them. They can switch the sequence, the logs and inverse. Doesn't matter, but just memorize it in this way. Ilate. And this you must choose inverse functions before logs. And before log, after inverse, you must choose logs. And after logs, you can choose algebra. Algebra, like we can say constant, or when you have x squared, you have x cubed, you mention those. So these are just normal trigonometric functions, the sine, cos, and even the sec functions, the cosec. And these are exponential functions. The exponential functions, e to the power of x and a to the power of x, you mentioned. So which means if, let's say, you are given inverse and exponents as a product, you cannot choose exponents before inverse as a f of x. You must choose f of x, or you must choose u as inverse before exponents. So we know that according to the formulae, can I use uv? I don't know your formula sheet uses uv. Let me just use u, and then this must be v prime in terms of x. So when we integrate the following, it will be equals to u times v minus integral of it must be u prime multiplied by v in terms of, let me say, in terms of x. In fact, I was not even supposed to say in terms of x here. Can just leave it in that way because we know this is d prime. Can say in terms of u, or can be du. Though we always use this x there, let me just leave x. But it's the f of x, and this is v. So we need to, oh, sorry about the pen. We need to choose f of x. So according to the sequence, we know f of x, or our u, so this can be u, it will be equals to. According to the sequence, when I'm seeing these two functions multiplying each other, algebra and logs, which one comes first that I have to choose? I must choose log as f of x. That's the first part. Cannot choose algebra because it comes after log. So I choose logs as f of x. So I'll say log 4 x to the base 3. It means the other one will be our g of x G prime, G prime, or V prime. It's either G prime or V prime. So I'm just putting this for you to see. You can use U or you can use V prime there. So f of x represent U and V prime represent G of x. So I know this will be equals to x. So the other one will be f of x. So I have U times V prime. U is log, G prime is that. I saw people derivating here while already this is a derivative. We need to integrate this to have G of x. We need to derivate this to have f prime. So f prime of x, we need to derivate. So derivative of this, it will be, we know that it's always 1 over the function multiplied by the derivative of what is inside there, which is 4. Normally you say divide by, it will be, now this won't be ln 10, because if we replace here, it will be ln 3 over ln 10. Or we can say log of 3. So replace 4x by e. So that is derivative of, that's derivative of log. 1 over the function multiplied by the derivative, replace f of x by e. Let me get water. And in the meantime with g, we have to find g of x. We integrate the following, because this is a derivative, we need to integrate. So we'll have x squared all divided by 2. X squared divided by 2. So not to waste time, I just want to simplify this f of x before we go further, the f prime to say. So simplifying this f prime, we can have log, can I say log e to the base 3 all divided by, because 4 divides 4 will be having x there. But some, they can simplify this and have, what do we call, I think it can be ln 10 over ln 3. Yeah, it will be over ln 3 at the bottom here. So according to the sequence, we must say f of x times g of x. It's u times v, and then f prime times g of x. F prime times g of x. And okay, sorry about that. So therefore, I'll specify that integral of the following: log 4x to the base 3 in terms of x is equals to. So it must be u times v, or f of x times g of x. So f of x times g of x. So we'll have x squared over 2 multiplying log 4x to the base 3. Therefore, must say minus, don't have space there, I'll just hijack this. So we'll have integral of, it must be now u prime is this one. So we have log to the base 3 all divided by x multiplying g of x. So it will be x squared all divided by 2. We have to integrate in terms of x. Now always in the second term we have to integrate, but you can't integrate. I hope you see already you have quotient of functions. X is there and another x is there. So we have to simplify first. So in the meantime, while we're simplifying this, we just have x squared over 2 log of 4x to the base 3. I just want to factor out 2 in the denominator. In the numerator, we'll factor out log e to the base 3. It's a constant, there's no x there. It's a constant, it's a constant. But x squared divided by x will be left with the integral of x there in terms of x, because we divided x squared by x there. And these two are factored out as they are constant. I think this resembles something in some of the tests that were written in T2 in my local campus. All right, so in the meantime, now we can say we have x squared all divided by 2 log of 4x to the base 3. Now we can integrate the function the x. So we know that our solution will be log the base 3 or all divided by ln 3, 2. Therefore, integral of x there we know is going to be x squared all divided by 2. Therefore, we can add the constant there plus c. So you will practice at home. Why are we having, or you'll sit down and revise logs, the base 3. When I simplify this, you will see that I'll have x squared all divided by 2 times 2, it's 4. And then if I express this using log rules, maybe I can play around that, but it's a waste of time. In some of the lessons, I once explained this. That according to log rules, if we have log of a to the base a, can express it as log of a to the base c all divided by log of over log of, or that was b to the base c. So if the logs are the same here, you can still compress and have log of a to the base star. So that's why when it comes to that one, I just want to express log of e and introduce the base e there, and have log of 3 to the base 3. So this will be 1 over, I know that log to the base e, because I said this base e, log to the base e, it's ln, then the angle there is 3. So that's why you will see that when we come here, I will say I'm dividing by ln 3, or it can be log of e to the base 3. So it's still the same. Let's see. Okay, thumbs ups if we have if everything's sorted, or if we can continue, you can mention, because it's the last one which is left. But if you feel like it's no longer going in, we can pause here and make time to wrap up the other questions tomorrow. Super impossible, the number 1 comment, and number you want to continue? Kwanya, who's Kwanya? Okay, 1 thumbs up. Oh, people ate things here. Now I don't sleep. Okay, I guess I have 4 hours of sleep. Okay, let's see with that last one, 4.2. At least integration is covered very well here. Hey, that was who's sleeping there. Okay. Does that thing exist? All right, 4.2 now. Yeah, this is the last one for question 4. We need to determine integral of y by resolving into the integral into partial fractions. So this one does specify that we need to resolve the following integral into partial fractions. I think at least we did cover partial fractions. 4.2. So we know that we need to resolve the following as 2x plus 7 all divided by, we need to factorize the following. It looks familiar to another problem we just did in question 5. Which was that one? I don't remember, but I think it was a combination of the functions here. Yeah. So we have x and x, factors of 2, it will be plus 2 and minus 1 to give us that initial expression there. So we know that we'll state that is equals to, if we're factorized into partial fraction, all factors will be shared or deduced into partial fractions. The first factor, which is x plus 2, normally it can be x minus 1, doesn't matter. Whatever is in the numerator will complement this. Therefore, plus b over x minus 1. So those are the factors we're having. Now, what we're going to do, we're going to multiply by this denominator in all and throughout the equation to state. If we multiply in this equation, we'll be left with 2x plus 7 equals 2. We'll have a, x plus 2 will be divided. We'll be multiplying by x minus 1. The second term will have plus b. X minus 1 will be dividing here, so we'll be multiplying by x plus 2. So even if you're used to letting x equals to 1, it's fine. You solve for b, it's still fine. Or you can go this route of making sure that you have, okay, let me just skip this step. We'll have ax minus a plus bx. B times that is positive 2b. So on the left hand side, we have common, what is it, linear function. The right hand side, we still have linear function 2. So we need to group the terms that consist of x together and factor out that like common variable. So we'll have a plus b, factor out x. Then let's group constants together plus. We'll have 2b, group it with minus a. So those are the constants there. So when we do the grouping, we want to equate the coefficients of x, on the left and right hand side, of the left and the right hand side. So that's what we're doing to deduce equations. So coefficient of x on the right hand side, it will be 2 equals to coefficient of x in the left hand, oh, this is right, this is left. So we'll have a plus b. That is equation 1. And now we need to equate now the constants. So when we equate the constants now, because constants, we are equating the constants now. So we will have 7, it is equals to constants of the right hand side, we have 2b minus a, because we have 7 on the left-hand side. On the right-hand side, the constants are 2b minus a, where we don't have x there. So now we have equation 2. So if we want here, we can substitute equation 2 into 1, or if you know how to use elimination method, you can say we want to add equation 1 with equation 2, or add equation 2 to 1. So when we add the following equations, we're going to say 2 plus 7, we're going to have 9. We're going to have a plus negative a at 0. Then we'll have b plus 2b. It is 3b when we have used elimination method or by addition there. So therefore it helps us to determine b. So b will be equals to 3. We divide on both sides of the function, or the equation, by 3. Therefore, when we are done, we can substitute b into either of the equations. We can see into 1, 2 into 1. Equation 2 into 1. So I just got a dix. Who is this? Okay, sorry about that. Okay. Let me go back. Sorry about that. All right, so let's substitute b into 1. We'll have 2 equals 2. So we'll have a plus, and b we said is equals to 3. But for a, it is equals to. So we take 3 to the other side, will be negative 3. Subtracting from 2, we'll have negative 1. So we can start that. Therefore, when we have is simplify the function into what we call into partial fractions. So a, we know that is negative 1, all divided by x plus 2. Integrate in terms of x, and therefore plus b, we stated that is equals to 3, all divided by x minus 1. Therefore integrate in terms of x, and therefore the solution will be equals to. So always linear of functions will always play a role in long division and partial functions. We inspect the denominator. If we derive, if it will give us the numerator, yes. Derivative of this is 1. So we can factor out that negative 1. We still have our derivative. So we now have negative ln of the denominator. Therefore, plus same thing, this, when we derive, we have to get 1. So that constant we know we factor out, can have ln x natural logarithmic of x minus 1 plus the constant. We are then what I call integrating the following by using partial fractions. Right, I hope all it's clear and makes sense so far on, or maybe on what we started from. we can conclude it here. I hope. I have a lot of papers here. Formula sheet. Okay, any clarity? Any clarity? And please rest, guys. One is time to sleep. So tomorrow you must sleep at 10 o'clock. When you are going for exam, you sleep early. Super impossible. Any clarity there? Oh, we're not sleeping today. Cross night. Karabile Chale Vanilla. This is super one to continue. We are sleeping. I'll see you tomorrow. I'll be sleeping. Yo, I'm tired. We'll do Hello Peter's rule tomorrow. Paid the papers. I don't even know where the question. Where's the question? I'm sleeping. At least you have the crown. Keep my At least you have the crown. You've been interactive. Now we'll look into the problems tomorrow. I even lost the form where the question paper. I admit I'm tired. So L'Hopital's rule, just to cut it, you need to make sure you it's not about just derivating. I saw someone yesterday asking me the question. It's all about finding the limit. If you can't find the limit by substitution, so it means that you can apply L'Hopital's rule y to please Laplace transform tomorrow. So using L'Hopital's rules, because you want to make the function to be in quotient form. When I say quotient in division, that's also that you can derivate the numerator and denominator independently. It's not just that we are derivating, we are trying to find the limit. So L'Hopital's rule, it simplifies the the problem on when to get the L'Hopital's rule. No, Laplace transform is similar to what we're doing, but normally we substitute. We are doing the Laplace transform operator, so we're just changing the function in terms of time, where we're having two functions there. We transform the function, but it's like when you're substituting the limit of infinity. Look into one question or video or link where we did substitution of infinity. Similar things. Right now, it's cut. It's 1:00. We can pray. All right, capiche?